Hey guys, Mr. Newton here. I am guessing that you might be struggling on some of this new stuff that I have here for you. So what I decided to do is to meet with you as face to face as I could and show you how to do it. So let's get right to it. What I'm going to do is quickly show you how to do this. Give you a quick little overview and then show you how to do a couple of these problems together. So let's get right to it. First of all, we're talking about light, and light is amazing. Light travels super fast, speed of light, which is 3.0 times 10 to the 8th meters per second. That's freaking fast. All right. But anyways, light also travels in waves. And so light has three aspects to it. We call it speed. We just talked about that. And wavelength, which is the distance between the two waves. And frequency, which is how many waves pass a point in a second. And that's it. Let me show you real quick. Okay, so here's the three parts of light that you need to know. Let's draw a wave right here. So that's our light wave right there. That sucker has a speed, and so the speed is going to be 3.0 times 10 to the 8th meters per second. Now, it's always going to be that speed. If it's not that speed, then the universe collapses and we all die a horrible, painful death. And that's not good. That's worse than coronavirus, kids. So right here we have the speed, and it's always going to be that speed. And so that wave is moving at that speed, right? And so then what we have is we have the distance between these waves, right? And this is a wavelength, okay? And that is always in meters, meters, not centimeters, not decameters, not picometers, but meters. So when we talk about wavelength, it has to be in meters when we solve for it, but then we can express answers differently. So we'll do a little bit of conversion practice. And then we also have finally frequency. And the frequency is, sorry about my handwriting, guys. The frequency is how many of these bumps pass a point in a second. So, so basically it's waves per second. And so let's say that in 1 second, these three bumps pass this point. Well, then it has a frequency of 3. And that would be 3 hertz. So waves per second is also 1 over s, or also called hertz. So here's our equation. So overall, our equation is c for speed of light. And they use the letter c because that's the first letter in speed of light. And then you have this lambda, because we all love Greek letters. And so that is our wavelength. So wavelength is right there, the lambda. And then we have F for frequency. And that one actually does make sense. Okay, so here we go. So speed is meters per second. Wavelength is meters. And frequency is 1 over s. So check that out. Meters per second equals meters per second. So you can use this equation to solve all of the problems on this assignment right here. So let me show you. Let's go ahead then and look at the first question real quick. It says we've got this electron beam strikes a block of copper, X-rays of frequency 1.07 times 10 to the 19th hertz are emitted. What is the wavelength of these X-rays? Answer in picometers. So we can change our answer at the end to picometers, but the equation always uses and gives us meters as the unit that we're going to use. All right, so I'm going to take this right here. So real quickly, for this whole assignment, this is your equation. Wavelength equals, or speed of light equals wavelength times frequency. So for this problem, they give us the frequency, so that's the one that they're giving us right there. We know what speed of light is, 3.00 or 3.0 times 10 to the 8th equals my wavelength times my frequency of 1.07 times 10 to the 19th. So pretty simple right here. All you have to do is remember how to solve scientific notation in your calculator. And so let's go ahead and do that. So we're going to have 3.00 or 3.0. I'm just going to go second EE. That's going to give me my scientific notation. So that's 3.0 times 10 to the 8th. And then I'm going to go divided by, in order to isolate my wavelength right there, 1.07 times 10 to the 19th. Ba-boom. All right, there's my answer right there. It is 2.8 times 10 to the negative 11th. 2.8 times 10 to the negative 11th, and that's meters. Now, take a look. The question tells us to answer in picometers, and so this is where we have to do one of those quick conversions like we did in the beginning of the year. All right, so the setup is really simple. You want to go diagonal with the unit you want to get rid of. So I want to get rid of meters. I'm going to go diagonal. And then I'm going to put the one I want to change it to on top or on bottom, just in the other spot. So diagonal to get rid of it. And then, so I've got my picometers. Now what I need to do is refer back to my metric multipliers. So here's that list again. So no prefix means 1. That's this guy right here, 1. And I'm going to go to pico. So if I look down here, I find pico right here, and that's 10 to the negative 12. So if I look at my separation here, so here's my meters to my pico, and that's 12 powers of 10 separation. And so what I got to do is then put it with the small one. So remember, they get smaller as they go down. So this is the small one. So I have 10 to the 12th, and just like that. So if I multiply that out in my calculator, I go 2.8 times 10 to the negative 11th times 10 to the 12th. It's going to move the decimal place 12, and so we're going to end up with 28. So 28 is my answer on that first one. All right, let's do the last one here as well, number 7, and then the rest of them you guys can do on your own. I think I should be able to just do this one right here on the paper. So here we have an electromagnetic wave. It has a wavelength of 625 nanometers. It asked me for the frequency. All right, let's do it. So here's my equation. Wavelength equals, or speed of light equals wavelength times frequency. I know what the speed of light is. It is 3.0 times 10 to the 8th. Now my wavelength, I don't want to just write 625 in there because look, that's nanometers and it has to be in meters. Remember, this wavelength is in meters. It has to be in meters. So I'm going to do a quick conversion here, 625 nanometers, and then I'm going to put nanometers down here because I want to cancel it. I want to put in meters right there. I'm going to look back to my, my thing here and figure out how many powers of 10 separate those. So I'm going from 10 to the 0, because I have no prefix, 10 to the 0 to 10 to the negative I. So that's 9 powers of separation. I'm going to put it with my small one. So always put it with the small one. And then you're going to go ahead and divide that, and you should get 6.25 times 10 to the negative 7th meters. Now I can put that in there, and so 6.25 times 10 to the negative 7th, and then I can solve for my frequency. All right, so should be just a simple little calculation at this point. So I got 3.0 times 10 to the 8th. I'm going to divide it by my 6.25 times 10 to the negative 7th. So divided by 6.25 times 10 to the negative 7th. And then bada boom, 4.8 times 10 to the 14th is my answer. So 4.8 times 10 to the 14th. And this is frequency, and the unit for frequency is hertz, Hz. So unit for speed is meters per second, units for wavelength is meters, and the units for frequency is hertz, and hertz just means 1 over seconds. Now it asks me, what region of the electromagnetic spectrum is it found? Now, I provided this for you in the problem on there, but this right here is another copy I've got, so I can show this to you. The electromagnetic spectrum. Okay, so I can look at it from 2 ways. I can do wavelength or I can do frequency. Since we solved for frequency, let's use that. So my frequency was 10 to the 14th. So 10 to the 14th is right here. And then here is my range right here. So if I look at this, it actually ends up right there in the infrared. So these are all your different kinds of light. So light is radio to micro to infrared, goes all the way up to gamma rays, which is what comes off of nuclear radiation. So if I just look at my frequency, I've got 10 to the 14th, so infrared. So that's my answer. The region is infrared. All right, there you go. That's how you do all these. Now, any of these right here, you can convert. As second to the -1, that would be frequency, just in case you guys know that, need that, because second, if you go second to the -1, that's the same as this, which also equals hertz. So that might confuse some of you, so make sure that you guys got that figured out. And other than that, you should be able to plug everything into here, solve for it. Make sure that before you solve, you get stuff into meters per second, meters, and then 1/s or hertz. All right, guys, so that's it on that problem, or all those problems. You should be able to get the rest of those done real super quick, easy. I'm gonna give you a quick little tutorial on the next problem set, and so stay tuned for that one.